Mr. Barry here with you for one last video, just to take a look at graphs and try to get as much information out of these absolute value graphs as possible. I got my parent function over here to compare to what we're about to do over here, and we know when it comes to absolute value functions at this point, hopefully, that we're always checking out the vertex first, and we're going to be using this equation to kind of help us move from there. So here, our vertex is this point right here, which we all know from just talking in class. For whatever reason, I don't know what it is, the x-intercept is one of those spots where writing down the point values are just kind of confusing. Maybe it's because we grew up on the number line. But this point right here would be the point. We moved from the origin over to, we didn't go up or down at all, so that point, the vertex here, would be 2, 0. 2, 0, which we know is an x, y situation on the graph, but in our function here, helps us out that we have h, k. A couple other things that we know, well, there's a lot of things that we know from the vertex. We know we have this imaginary dotted line that we can draw in as our axis of symmetry. Here the axis of symmetry would be the line x is equal to 2. We use that axis of symmetry to figure out the slope to the right side of the mirror, because that would be our a value for this picture. And I go to my point vertex right there, and I'll just work it to the next point that I see. So I go up 1 and to the right 1, 2, 3, 4. So again, when it comes to that, we went up 1 and to the right 4. As a slope, simplifying that out, that means that our slope is 1/4. But we know for absolute value functions that slope on the right side of the mirror is really what we're going to have, our a value. So it's where it's applicable to us in this problem. 1/4 is equal to a. So I can take that information and go ahead and plug it in to our function that's very common right here. Y is equal to a times the absolute value of x minus h plus k. We'll replace the a. The a is now 1/4. We'll replace the h. Remember now the x is part of the equation and the minus sign is part of the equation. So we got to leave the x in there and we leave the minus sign in there. Our h value is 2. And then our plus k would be 0. So that's our equation right there. If you write that out, that's perfectly fine. There's nothing wrong with that whatsoever. However, you might see that same exact equation written like this, because we know that adding 0 is kind of one of those identity properties. It's not going to change anything. So there's a very, very, very decent shot that we'll see y is equal to 1/4 times the absolute value of x minus 2 without the plus 0 on the back end. They mean the same exact thing, and we got to be careful with that if we were working the other way and we had to figure out what h and k is. Definitely have to figure that out. So a couple things that I need to check out here. The first thing I want to do is just kind of compare the graphs together. We've always compared the vertex first, just the same exact order in which we check things out when we started off. So the vertex here is on the origin. It moves a little bit over to the right. It doesn't go up at all. It doesn't go down at all from there, but it definitely moved over to the right. So if I'm taking a look at our picture and I'm trying to make comparisons between the two, we know that we move this graph to the right, 100%. It might not have been as obvious in other examples, but in this example, hopefully, especially comparing the two side by side, we can see that the picture over there is definitely a wider V than what we have here. Again, we're basing all of that off of our a value. Our a value over here is 1/4, and it made our V wider. So I do want to mention that the width here is wider. I believe in the last video I said the one was skinnier. I think I also spelled the word skinnier wrong, but here it's definitely wider over here compared to our parent function. A whole lot of information we can get from one picture. And hopefully at this point you understand this would be a great opportunity here. Hopefully you've been jotting down notes that if you have any questions, you make sure you reach out because there's a lot of information here. But it does, hopefully you understand how it kind of works all hand in hand with one another.